All right, we are back and we're on Theorem 8. We're still continuing with our work on tangents, right? So in this particular case of Theorem 8, we have a unique situation, right, whereby we are provided with two tangents, tangent AB and tangent AC. Now, what happens? The tangent starts from point A, or the tangents rather. They start from point A and then they go towards the circle, towards B, and towards C. Now, what happens? The distance between point A and B and the distance between point A and C, it is equal. Let me repeat, the distance is equal. And when the distance of these tangents is equal, that is what we call equidistance. Equidistance. Now, in this particular theorem, Theorem 8, our job now is to prove that tangent AB, the length of tangent AB and the length of tangent AC is what? Is equal. Now, you may see that I wrote here on the side that 4 conditions of what? Of congruency. When we tell you grade 11s that study of conditions of congruency, you think, oh, it's grade 9 work and then it's we are bothering you. However, in order for you to solve this particular theorem, you need to know the 4 conditions of congruency and you need to know which one are you going to use. So what are the 4 conditions of congruency? RHS simply represents right angle, hypotenuse, and any other side. Condition 2, angle, side, or condition 3, side, angle, side, or side, side, right? So when I'm going to solve this, I'm going to choose the first condition of right angle, hypotenuse, and any other side. But I'm talking about a right angle, I'm talking about a hypotenuse. I don't see a triangle here. Remember, in geometry, you are allowed to add things that are not provided by the examiner, on condition that you are going to announce to the examiner that you are going to add some things. You just don't do as you please, right? So what is the first thing that I'm going to do? Now, here I'm given that O is the center, this dot here. So what I'm going to do is that I'm going to now join point O to point B as well as point O to point C. But like I just said, I don't do as I wish. I tell the examiner. So I come and I write join OC and OB. Now let me go ahead and join. All right, there, I have joined. Now, remember, where did I join? I joined from point O, which is the center. Very, very, very important. From the center to the radius, what do we call that? From the center to the circumference, we call it the radius. I've already given the answer. So line OC and line OB, they are what? Radius. Meaning to say that this line is equal to that line, right? And if you know your properties of a kite, you see, oh, these shorter lines, if they are equal, and these longer lines, we are proving that they are what? Our job is to prove that they are equal. It means that OB, actually AB, OC is a kite from where we are looking at. So now I come here where I announced that I had joined OC and OB. I start to give my reasons. Now I say that line OB is equals to line OC, and my reason would be radii. Remember, the plural of radius is what? Radii. 1 mark for saying that the sides are equal, another mark for giving the reason. Now, what else am I going to do? I see that now you've got the radii. Now, observe, I have got point O and I have point A. So I'm going to join point O and A. I tell the examiner that join OA. I don't do as I wish. I'm not R. Kelly. I wish. I do what the examiner wants. Now observe, when I've joined OA here, what do I have? I have a what? I have a common side, because check, I've got this triangle on this side and I've got a triangle on that side. Triangle what? Triangle ACO and triangle ABO. And OA, line OA is found on this triangle and that triangle. So now I say OA is equal to OA. My reason, I say it's a common side. Now, there's one thing which I didn't mention after constructing this radii. Remember, from the center to the circumference, this is radius. And I've got a tangent. And on our previous theorem, what were we talking about? We were talking about the fact that a tangent and a radius, they are perpendicular. I mean to say that here we've got 90 degrees. There is our right angle, right? So, meaning to say that if angle C is equals to 90 degrees, it also means that angle B is equals to 90 degrees, because it is also what? Tangent, which is perpendicular to the radius. So I come and I write angle B is equal to angle C, which is equals to 90 degrees. And then my reason, I now say the tangent tan is perpendicular to the radius. Remember when I started this, I said that I was going to use what? Right angle, hypotenuse, and other side. So angle B is equals to angle C, 90 degrees. There is my right angle. Mark. Then I need a hypotenuse. But remember, the side opposite what? The 90 degrees. This line OA is the hypotenuse, which I call the common side. Check. And I need any other side to on the triangle. And I spoke about what? OC being a radii, which was any other side. Check. So now I tell the examiner that, okay, I've got RHS, right angle, hypotenuse, and any other side. And because of that, now I can conclude that line AC is equal to line AB. So I say AB is equal to AC. Therefore, and just like that, I have proven theorem number 8. I hope everybody understands. Please don't forget to share, like, comment, and most importantly, subscribe. Thank you very much.